So for this week, you will have the topics. We'll start with Clifford. I'm going to share the session agenda, so you can actually see how we will go through the week. So if you'll see here, this is day one. So the agenda, you should have all received the agenda. If any of you were not in the list that I was sent, please ask your colleagues from your university to share with you. A few logistics. Each one of you, we can see your names. And basically what we have is like, you can use the chat to type your full name. And for the universities where we have PPU, IUG, and Al-Quds, and there are several of you there, if somebody can actually go to the Zoom account and you can actually type the full list of the people who are there. So I can see, for example, PPU, I think I can see 5 people there. So from PPU, if you put 5, 6 names in the chat, so we can use the chat as the attendance. Okay, now what we have is like every week we have every day of the week we will have mostly 2 sessions. Apart from tomorrow, we have 3 sessions. The recordings will be made available. Any slides or materials will be made available also by the speakers, and we will share later on. And then if you'll see from the first day, we have Clifford. And Clifford is our, I would say, sometimes I call him Mr. Cisco, but actually he is one of the pillars of our networking programs. He's one of the reasons why our networking programs get almost, or actually it's not almost, they get 100% satisfaction rates. Very good friend of mine and really an amazing instructor. As you know, this week we will be delivering you a variety of topics. In some of the topics, the emphasis will be on the topics that you need to cover to have state-of-the-art teaching and training for your consultant students. In other words, the emphasis is that we're teaching you areas that you can teach for students who can be freelancers and they can have state-of-the-art topics. At the same time, we've selected professors and instructors who are capable of teaching with innovative ways, creative ways, and so on. For example, tomorrow, I'm going to be showing you, I'm talking about management information systems, but I'm going to be showing you how we use different tools to do the instruction and how to organize the lab. So tomorrow, it's kind of a surprise. I'm going to be doing my session. I timetable it together with my lab sessions. So in tomorrow's session, we will be going live from Middlesex University labs. That's going to be a logistical nightmare, but you will see how to teach using different ways of technology, different technologies, and so on. So in the first day, Clifford will start. We have a 3-hour session. So Clifford, obviously, take care of any breaks. Obviously, like it could be that it is 2 or 3 sessions with some interim breaks. I would say that either Farzad or Bahare will sort out the recording. So Bahare, Farzad, when there is a break, make sure that the recording is paused. I hope Cliff, okay, so yeah, okay, confirmed, that's good. And also, Bahar and Farzad, if we have somebody, when you have all the names, to create a list at the end of the session so we can have a list of people who attended. We will need the list. So one of you, please maintain a spreadsheet for every session, Monday to Friday morning or afternoon sessions. At the end of the session, guys, at the end of all the sessions, Middlesex University will provide a stamped and signed certificate of completion of your training if you've done all the evaluations, or certificate of attendance if you've done only a few sessions. The agenda shows you the times, British times, and also it gives you, of course, the Zoom link. So since you're here, you know already how to use it. What I need you to understand is at the end of every day, we have a link here, which is a Google form. It's a very, very simple Google form. It really takes only 2 minutes, where you will be evaluating both sessions of the day. So fill it in, to make sure that you provide our evaluations that we can use to report about the quality of this training. In the afternoon, you have Usama Rusi again from the networking department, and you have security and cyber security issues. Tomorrow morning, we have a consortium meeting for coordination. So any of you who are not in the committee of managing the REACH project, you do not need to attend. This is for us to coordinate our project. And then what we have in the afternoon, this is me, where, as I said before, I'm going to be showing you how I teach my management information system courses. I will show you some innovative ways of teaching. And also we will do a sample of, I will not show any kind of state-of-the-art topics, because management information systems is very, if you like, very established area. We will talk though on a topic called globalization. So one of the sessions that I will be doing is on globalization and how important it is for our students to understand the global nature, because we have the freelancing theme. Then for 1 hour, we will have Alan, Rabbi, and Claire giving us an idea of how our employability services and our student services operate in our university. I can see that IUG already started having problems with the technology, so this is why we need the recording. Farzad, Bahare, the recording is critical because we don't have stable, we may have issues with connectivity with our Palestinian partners. On the third day, we have Kai throughout the day. He's going to be having a more practical session on web application development. On day 4, we will have Giovanni in the morning talking about data. And as you can see, he has 4 different sections that he will cover. And in the afternoon, we have David Windrich, who's going to be focusing on machine learning. And on the last day, we have Ariadne, who's going to be focusing on data analytics and visualization using the Tableau platform, followed by Magdi, who's going to discuss about AI and machine learning from a cybersecurity perspective. So I hope the agenda is clear. If you have any questions, feel free to ask them now, or if you want to put them in the chat. I will just pause for a minute for any questions, guys. Clifford, you ready?
Yes, I am.
Clifford, if you can liaise with Bahar and Farzad. Bahar and Farzad, you choose who's going to be actually collecting materials from our speakers. Hopefully on Friday, we will have them in a folder to be able, any slides that you can share, Cliff. I've made clear, and I'm going to say this on the record as well, any slides that we use are the intellectual property of our staff and of course Middlesex University. As part of this project, we're happy to share ideas and give guidance, but please do not use as is unless unless agreed with the instructor. Actually, it's very good. We can see, I see Usama is getting connected now. Cliff, just give me a minute for Usama to connect. Usama, sure. Good morning. Thanks for joining.
Good morning, everyone.
Usama, guys, is our speaker, again, an excellent member of staff from our networking specialism. Usama is the speaker for the afternoon session. Usama, I'm not assuming that you're going to stay for the entire day, but it's good that you made contact.
Yeah, no, I thought I'll come in this morning, say hello, and then I'll join you later on.
It's good. That's perfect, and it's perfect timing because Clifford was about to start. And as I said, we will have you in the afternoon. You have 3 hours. Feel free to manage the 3 hours as you wish, how many breaks you want and so on. Please make sure that Farzad and Bahare, who are our GAAs, have some slides or any materials you want to disseminate for the, because obviously the training we provide, the materials they have is this video recording and of course the slides of the materials that we cover. The focus is for our Palestinian partners to be able to replicate whatever we teach them, because they will be designing their courses to support students getting increased employability opportunities by doing similar courses of what we do this week. Okay, so Cliff, I'm going to stop talking for a change, and floor is yours.
Hello, George. Thank you so much for that introduction. You put me under pressure by giving away all the secrets that we've shared for so many years, but never mind. I would be here until 12, George. Unfortunately, I've got a few other chores to take care of after this session, so I'll do my best to keep an eye out, like you said. Good day, everybody, my friends in Palestine, and I think in Jordan. I'm not quite sure where all the rest are. It's really good to see you. I hope you can hear me and you can see me waving at you. Greetings. Thank you very much. Greetings all. Okay, so welcome to the session. I've been tasked with opening up this training session, and you can imagine that puts a whole lot of pressure on me, but that's okay. After 20 years of lecturing, you still feel the pressure when you get into the ring, as they say, because you take it extremely seriously. So I'm glad to see you all here. So I'm going to share my screen with you just first, so that we can visualize what we intend to do today. So I'll share my entire screen so it makes it a lot easier for us to navigate. So let's look for my slides. Okay, so I've got some set of slides here which I'm going to expand, and hopefully I try to manage my screen as best as I can with all the extra windows that are opened. So let us start by playing these PowerPoint slides for you to get a better presentation view. Okay, so we are here today because there is a series of lectures we want to be able to go through. And what I'm hoping to do here is not so much teach or lecture, but also to give you an idea of how I would go about doing my training sessions or teaching sessions in the classroom with my students. And as George, my colleague, said, I'm a computer networks specialist. A focus has been on Cisco networks. And in doing Cisco's, we've had to certify as network instructors so that we're able to deliver the contents to our students, not just from the theoretical part of the subject, but also to be able to get your hands dirty on the routers and switches and learn how to configure them. So I can imagine for those of my colleagues who might be teaching networks around the world, would want to be interested in doing some Cisco certifications because, as you know, the world is changing really quickly. It's very dynamic. So there'll be need for you to get those certifications on board so that, you're able to deliver not just the theory, but also the practice with your students. So here's our first topic. And what I hope to do with you, if I take too much of your time, as you know, lecturers can talk all day, I think it'd be nice for us to get maybe like a water break or a coffee break or tea break, sort of 15 minutes after the hour. So it's now 9:20. I reckon by 10:30 maybe, we could pause for a 15-minute break. Okay, so we do that at about 10:30 and then finish off the rest of the session when we get back 15 minutes afterwards. So my topic today is software-defined networking. And the reason, George said there was a project going on and we had to, come up with some exciting things to do with you during this session. Now, as you probably know, or maybe experienced, online training or teaching can be boring. And it's really, really down to, personalities, how well you interact with your audience across, the network space. You remember, you're no longer face-to-face. It's no longer in the same room or same location, but we've got to be able to communicate across successfully and to be able to express our attributes in teaching as well as we can. So I'm going to do my very best with you. And I hope you can hear all that I say and my pace is not extremely quick. So what is SDN? It's a question that is asked, quite around these days. And you've had various answers. Software-defined networking, should I care about it? Well, I think you should care about software-defined networking for a good number of reasons. And so we are going to try to see why SDN is important and why we should care, okay? So it's my slide doing its thing here. So like I say, we are going to start by introducing the topic and hopefully I can get to the next slide. Yes, I can. Okay, so what exactly is software-defined networking? And that question is often asked across the board. And I've asked my students a number of times what they understand by SDN. To understand SDN, we're going to go through a number of things. And here I have a content list, of the sort of things we can discuss to be able to understand the actual topic itself. But just like anything else, before we try and put some expression or to be able to expand the topic SDN, we need to first of all have a look at where we've come from, you know, the evolution of networks. You know, traditional networks have been around for a long time. And we need to think about, you know, the sort of problems we've had to deal with in traditional networks. So we have a look at the evolution of the traditional network and how we've gotten where we are today. It would just be a small overview. And then we'll look at something quite interesting, but I think it's important for everyone in networking to understand is the point of demarcation. You know, at what point do we change management? Who's responsible for what part of the network? Now, I'm sure, you know, you're possibly thinking, yes, there are quite a few people responsible for different parts of the network, and they all have to sort of work together. But human beings are a problem. As we know, human beings are the weakest link. And so we're going to have a look at the points of demarcation and see where the configuration change management stops and changes as we go along. So, and then we have a look at why we need software-defined networking. What are those huge benefits? What are those advantages that we could leverage and apply them to our existing networks so we can benefit hugely? And then, of course, an overview would be nice of what the actual subject is. And then we're going to expand into some solutions and have a look at Cisco solutions for SD-WAN. We have a look at Silver Peak solutions. There's several solutions out there, and we just mentioned a few of those. But we'll focus mainly on Cisco's SD-WAN solution. And then it's important to have a look at SD-Access. Yes, it is software-defined access, but that's kind of different from SD-WAN, and we'll see that as we go along. So here is a slide sort of portraying, you know, how far we've come, you know, the overview of networking. And if we consider where we are today and look at what we've had previously, the first thing that gets to mind is, you know, there's a lot of complexity in our networks today. You know, we're so in demand for data. It has to be quick. You know, applications are getting a bit more hungrier. They need a bit more bandwidth to be able to deliver quality of service to the end user. But, you know, if you have a look at this little diagram on the right, you know, the networks have been around for a while. You know, they were simple, connectivity wasn't excessive, you know, spaghetti junctions were less, but today's networks are a lot more complex. Today's networks are a combination of wired, wireless connections, traffic all over the internet, moving in every possible direction and constantly changing. That is madness. I mean, could you ever imagine how to manage a network as complex as that, with all data moving around in different directions and changing all the time? However, this change has come upon because of our requirements, you know, requirements in security, requirements in performance, and so on. So we've had to modify the existing traditional network into a network that sort of does everything we need it to, but has introduced a whole lot of complexity. So networks are becoming a lot more difficult to manage. And because they're becoming a lot more difficult to manage, there has to be a simplified method of applying that management across a network fabric. So it's interesting to see how we've gotten to where we are today. And I think it's pretty obvious that, you know, with expansion of IoT and multiple devices all over the internet that are mobile, the networks were always going to be difficult. It is easier to manage devices that are static rather than devices that move around, as we possibly aware of. So our networks are getting a lot more complex, and we need a simplified method to be able to manage that. Are you already thinking like I'm thinking? Is that going to lead us to what SDN could do for us, software-defined networking? Well, we'll soon find out. Well, let us have a look at the second point on my schema. Now, I talked about the points of demarcation. Now, we're still trying to understand why we're going to need SDN as a network paradigm. Well, let's think about some of the problems we face with our traditional networks. Well, in our traditional networks, having a look at this visualization, the point of management changes as data moves from the source to its destination. I'm sure you've got to agree with me that internal networks are managed differently from your ISPs. And I'm sure you've also got to agree with me that within your internal network, you would have individuals that are allowed to configure certain devices. It's not the same individual that configures all of the devices across from end to end. It would be nice if that was possible. In that way, we could avoid errors, or we could have some sort of consistency. But then again, external to the networks, even within the ISPs, ISPs don't talk to themselves, do they? They don't necessarily ask one ISP to come in and have a look at their setup and how the network is set up internally. Well, they honestly do not do that. And of course, there is this problem with human beings. That's the problem where human beings simply make a whole lot of mistakes and we do not communicate effectively like we should. So if you have a look at this setting here and the points of demarcation, the management of a network changes from time to time. So the point of demarcation really looks at the point of change of network control. What that simply means is, at what point can you apply your configuration? Who is responsible for the network at any given point of change? And as we know, network management moves from enterprise to ISPs. It is completely different. So there's a whole lot of problem with people. Now, SDN, a topic that's been floated around for a while. Who are the main drivers behind SDN? Well, funny enough, the ISPs, the network service providers, are the main drivers behind SDN. The reason for that is pretty simple. And if you look at what we experience and with our service providers, we never quite get the service levels that we agreed prior to going through the contract. Well, you agree a certain service level from a service provider, they never quite deliver those service levels. And in fact, from popular surveys that have been done, I'd say 30 to 40% of customers experience a poor service level from their service providers. Well, I think it's pretty obvious why the service providers find it difficult to deliver the service levels that are promised. Well, think about what we started with. Networks are becoming a lot more complex. But can you imagine what the life of a service provider would look like in managing thousands and thousands of customers, generating loads of traffic from different end devices? And some of these end devices are mobile, extremely difficult. So the job of a service provider is extremely complex with a traditional network. So service providers are those driving for SDN. And the reason they drive for SDN is that SDN promises to do less, or rather to provide better services with less. Now, how's that going to work? Automation. With automation, you can achieve a lot more with less effort. And with automation, you can get rid of the human error that we often experience. With automation, you can have consistency across deployment. So network service providers are clamoring for SDN because of the drop in service level agreements. They want to be able to sit back and do less and be able to deliver the service that is required by clients. So you will find that push for SDN, network service providers are big advocates for that to come into play. So we talked about what the demarcation is, and we've also introduced some of the issues faced by SDN, faced by service providers, and how they're clamoring for SDN. So points of demarcation is an issue, and that could be fixed, hopefully, with software-defined networking. So why do we need SDN in any case? Well, if you think about what we've just highlighted, the conversations we've had about the complexity of the network, and if you also go back to the service providers and think about how they could deploy network services that meet the service level agreements that have been signed by their clients, how could they achieve this? Well, automation is one word that comes to mind. So let us have a look at some of the promises that we could get with SDN, some of the attraction to software-defined networking. Before we go into the intricate details of what SDN really involves in terms of controllers and the rest, let us have a look at an overview of some of those benefits of what we're trying to achieve. To reduce the complexity of networks based on traditional networks, we can have centralized control. And the idea of centralized control is to have a controller that coordinates all the hardware. So as we're probably aware, some of us might know that a switch or a router would have several planes. But we'll leave that for now and let's have a look at centralized control. So to be able to control a network centrally just makes it a lot easier to be able to deploy a whole lot of instructions to all the hardware. And you can do that consistently. And you can also do that through automation. So centralized control, we can get that by controlling all of the devices from a central point. Open networking, well, that is the software we need. Now, recall the problem we have with human beings making a lot of mistakes, human beings, being involved in the configuration of networks, and also humans being responsible for some administration of some networks. We also discussed the problems of not talking to each other because, there are separate ISPs. An ISP is certainly not going to invite you to have a look at the internal networks. That's not going to happen. So to get rid of the human factor, we need software. And that's what open networking gives us. We need software that is standardized, that replaces the human. And that software could provide the sort of automation that we're trying to achieve. So with software-defined networking, we can get centralized control. We can get software driving the application itself and delivering automation through open networking standards. And then we can leverage virtualization. Now, virtualization is a concept that has been around for a while. We can leverage virtualization, meaning we can create the resources that we need. We can create our networks by defining those networks through software. So once we've defined those networks through software, we can begin to populate them with functional virtualization, functions like firewalls and routers, load balancers, and all the rest we need. So software-defined networking promises to eliminate the complexity of traditional networks. And it also promises to eliminate the errors introduced by the lack of consistency. So with SDN, we can solve that complexity, hopefully. And there are several flavors of SDN around that you might want to play with or that you might be aware of as well. So we've introduced the concept of software-defined networking. The concept of SDN promises programmability, meaning we can change the network on the fly. Right now what we do with networks is you've got to go under the hood of a router and go into the CLI and try to access the command line and maybe apply some new routing protocols or change an IP address on an interface if you wanted to. But wouldn't it be easier to have an external controller pushing all of those instructions to the hardware? That makes it a lot easier if we can do that. So SDN is programmability. Now, there are two sides to SDN. As you probably know, if you're into networking, or even if you're not into networking, you would be aware that an internal network is completely different from the external network. Well, the internal network could be your home network, could be your office network, or could be an enterprise building, or could be an enterprise network like Middlesex University, for example. Enterprise networks are built differently from the WAN because we know the WAN is a wild, wild west. It's the internet when nothing is secure. So often in the WAN, we have to be careful as we traverse. How do we push our company's data from one point through the WAN to another branch? One of the problems we've had to deal with in the past is use technologies like MPLS. Across the WAN, bringing two branches together, we can use MPLS to bring those two branches together. We can push the data from one branch to another using an MPLS cloud. Well, that works, but there are problems with MPLS. We can also use DMVPN, if you've ever heard of the dynamic multi-point VPNs. Well, if you've heard of VPNs, with a VPN, you can connect from one end to another securely by using a tunnel through the internet, and you get some encryption on that. But again, there are problems with that. So with SDN, we overcome a lot of these complexities that MPLS and DMVPN will introduce. However, DMVPN is still attractive in industry to bring branches together to be able to communicate like they're in a single location if you wanted to. But there's something exciting brewing, SD-WAN. SD-WAN does exactly and more what DMVPN does, and does exactly and more what MPLS would give you, bringing your branches together. So it is important that when software-defined networking was looked at, it was defined in two categories. The two categories are software-defined networking used internally. We'll have a look at that, and that's SD access. And also software-defined networking used in the Wild Wild West, and that's SD-WAN. But before we look at SD access, which is used in the enterprise, let us have a look at SD-WAN. Let us see how we can bring, communication from one branch to another. I mean, what sort of things do we need to be able to achieve this? So, there is these days, there is a multi-cloud approach that is used by a lot of organizations. The cloud is a great place to be. It's great because, the total cost of ownership of running a business reduces greatly. We can use software as a service if we wanted to. We can use infrastructure as a service. And some of these organizations providing these services give us some really, really good deals. For example, the Salesforce and Office 365 as software as a service that we can leverage through the cloud. And for the infrastructure, many of us will be aware of AWS and Google Cloud Platform as well, Microsoft Azure, and quite a few of them are out there. And there's also desktop as a service. That makes it even more exciting. And that's another area, and that SD-WAN, makes things a lot exciting for clients. So with SD-WAN, we're going to get a lot more reliability and security because we're able to form these paths that do not rely strictly on a defined route. We can have dynamic routes being set up through IPsec, and also we can have multiple paths to be able to navigate across the SD-WAN environment. It's quite agile as well, okay? It's an agile environment because it's very easy to spin up new branches, very easy to deploy new switches and routers across the network. So for example, if you've got a branch coming up in a different zone, all there would be a specialized router that announces itself to the Cisco platform system, and it is pre-configured remotely and joins the SD-WAN network for your organization to function as well. And of course, finance is the great deal. Cost is extremely low compared to traditional networks. Of course, the initial layout is expensive, just like everything else. You've got to upgrade your gear, your devices, your iOSs, and the rest of it. And of course, purchase some good connections that you would require for SD-WAN to function properly. But overall, if you look at the total cost of operating costs for running SD-WAN networks, they're a lot more reduced compared to our traditional networks. And of course, there's the point of using virtualization in an SD-WAN environment. I mean, you reduce your implication of using hardware and implication on the atmosphere of sort of the green gases that are, so you can be green by using SD-WAN. That makes it a lot attractive. And of course, there's the reduced risk as well. Okay, so far we've discussed SD-WAN, and we're trying to understand some of those advantages. Let us visualize this thing. Let us see what it looks like. Software-defined WAN, software-defined wide area networks. Well, we're going to need WAN connections to be able to get to branches to be able to talk to themselves. So to our left, we've got a branch that allows us to connect to branches on the right. So at the top of this particular slide, we can see that we have an SD-WAN overlay, and just below that, we have an underlay network. That's our physical infrastructure. So how do we visualize SD-WAN? Well, SD-WAN is not going to run on its own. It needs to have an underlay network. Just like anything else we do, if you think about VPN, for example, when you set up a VPN between yourself and the head office, for example, well, what you're doing is you're leveraging the underlay network, the existing transport network, and you're simply going to use software to create a virtual path that is secure. Okay, so that's just an example of overlay. So with overlay, we've got our software that creates this wonderful path we could use that is quicker, because that's what we're trying to achieve. Speed, performance needs to be improved. So we want to reduce the complexity of using the underlay network. If you have a look at the underlay network, we've got multiple routers to get from one end to another. The idea with the overlay network is to reduce the amount of processing, okay? Reduce the amount of processing by all those routers and the physical infrastructure. We can just, overlay that with software that allows us to go directly to the branch. Now, the only way that's going to be achieved is to use this thing called the controller. Now, if you remember, I said right at the beginning of this session that a router or a switch, or a firewall, for example, would have a number of planes. It would have its data plane, which is the physical plane, where the application specifics, integrated circuits, boards, circuitry boards are working. That's just simply what does the heavy lifting of moving data across different, switching it across different interfaces. Above the data plane, we've got the control plane. Now, the control plane is the brain of the device, the brain of the switch, the brain of the router. That's where all the instructions are developed. Those instructions in the control plane could involve things like, routing protocols, configuring OSPF or EIGRP or ARP and the rest of it, STP, all goes on the control plane. That's the brain. Now, the control plane would instruct the data plane on what to do with the data, where to forward it. And just above the control plane, we've got the management plane. And that management plane is where we interface with a router using Telnet, for example. Well, never use Telnet unless you're local, because Telnet is, as you know, is unencrypted text. Well, Telnet, for example, could be used to access the management plane through the VTY lines. We could use SSH, for example, Secure Shell, better use SSH rather than Telnet to access the management plane. But here's the deal. Here's the deal breaker. The deal breaker is now we've got boxes with control plane and data plane. So if you wanted to configure a box, you'd have to jump on it and go into the CLI. Well, to make things a lot easier, SDN as a technology splits that box into two, takes the control plane away from the device and leaves the data plane and the management plane right there. It extracts the control plane and stores it in a central location. So hence, if you look at overlay, SD-WAN overlay, virtual infrastructure, those routers, those devices at the branches, no longer have some sort of controller on them. So that controller has been extracted and it's now central. Well, the good thing about the central controller is that we can push configuration, or we can blast out configuration to all of the routers that are connected on the overlay. Okay, so we get an idea what the overlay is. The overlay allows us to bypass a lot of the processing that is done by traditional routers and to be able to create a secure connection from one end to another. Now, that's very attractive, I think. Attractive in the sense that we avoid all the unnecessary delay. It is no longer rigid. It is dynamic, and it's extremely quick, and it's cost saving. Some of the things we mentioned already. So we get an idea. We need an overlay on top of the existing traditional transport network. And that overlay allows us to achieve some of those things that we've been talking about: central management, dynamic allocation, and the rest of it, security, as a few that we've mentioned. So it is important that you get to know several flavors of the SD-WAN solutions that are around today. And being a Cisco instructor, I'm in love with all things Cisco's, but I'm not adverse to other platforms like Juniper, Arista, and the rest of them. So you need to be aware that when you do your practice or when you have a look at SD-WAN solutions, it's often necessary to sort of spread your tentacles and have a look at several solutions. The reason for that is they implement SD-WAN slightly differently, okay, where the controller is not necessarily all the brain. Some of the brain is left on the devices themselves, and the brain is split between the controller and the devices. And you would often see that in a Cisco ACI, application-centric infrastructure, where they use an APIC controller, okay, policy infrastructure controller, where some of the brain control is done on the ACI and the rest of it is done at the data center itself. So several flavors of SDN solutions are available. For the purpose of this session, we are just going to focus on Cisco SD-WAN that is delivered by Viptela. Now, some of you have heard about Viptela, the company. They've been around a while, and Cisco acquired them because they came up with a wonderful SD-WAN solution that leverages the Cisco ACIs and APIC controller that is used at data centers. Okay, there's also FortiGate SD-WAN, which is very popular, allowing us to deliver good security. FortiGate does a lot of security technology, as we possibly aware, and FortiGate really focuses on security solutions in the SD-WAN market itself. So it's good to be aware of these solutions and to have a look to see which of those or a couple you might want to work with. Now, just talking about solutions, it's important as academics that you leverage the open market, the open standard, free software. Now, one of the first SD-WAN platforms that I built, when I got into SD-WAN and I wanted to experiment, I was to have a look at the Open Foundation, Open Network Foundation, ONF. And as we know, open software allows us to get down to the detail of what we want to do rather than proprietary software. And that community grows quite quickly. If you look at GitHub, for example, you've got a whole lot of code and applications that could be downloaded and built. So the first SD-WAN experience I had was to look at ODL, the Open Daylight Controller System. Now, Open Daylight Controller System is a project that's been going on for a while. They offer you different flavors of ODL controllers that you can integrate with your system, with your SDN platform. And with the ODL controller, you can download several flavors of that from the Open Daylight project and install that on your laptop or desktop. Now, that can run in a Linux environment, so you might want to have a look at virtualization, or if you've got a Linux box already. So ODL allows you to use an external controller connecting to Mininet. Mininet is an example of an application that allows you to build virtualized switches based on the OpenFlow protocol. We'll have a look at those in a minute. So for those of you who might be interested in playing with open source software, have a look at the Open Daylight project. And several controllers that are available. And I remember the last one I played with was Carbon. Okay, so you come across several controllers there. But for SD-WAN solutions, these are paid SD-WAN solutions, proprietary solutions. Cisco, Silverpeak, FortiGate, VeloCloud, and Fortinet are just a few of them, okay? So let us be aware of those. In my next slide, I want to focus on the Cisco SD-WAN solution. And in focusing on this solution, there's several things we can do. And as mentioned, that this is driven by Viptela. And of course, Cisco also has, an alternative to Viptela solution. We've got the Cisco Meraki SD-WAN solution as well. Very attractive solution because of the location identity feature that we have with Cisco Meraki, being able to use the Cisco DNA, if you've ever heard about that. We'll see that in a minute, to be able to coordinate our devices and locate those as we require. Now, Cisco Meraki is popular for triangulation, as we've possibly heard about the triangulation technology where routers are able to triangulate your signal. And this is very useful for asset management, for example, and the tracking of individuals, okay? So there is Cisco's offerings, Viptela being a popular one, and of course, Cisco Meraki as well. Now, what does Viptela offer? What do we get? Well, there are 4 areas I would like us to focus on. Now, with a Cisco SD-WAN solution, we get a secure architecture. What is this secure architecture? We'll see it in a slide in a few minutes. We're looking at the components of SD-WAN solution that Cisco uses. And these components are able to interact securely to be able to provide the authentication that is needed in the network and the orchestration that we require. We'll have a look at those in a minute. And then there's the fabric operation. What is the fabric? Well, the fabric is the overlay software, remember? Okay, because we said SD-WAN gives us an overlay software that is going to run on top of the underlay network, which is your traditional network. Well, how do we operate that fabric? The fabric operation is important to the SD-WAN solution, the Cisco components. We also need to have a look at policies. How do we deploy the policies to our controller to be able to control a number of routers within our network, for example? How do we deploy policies to enable a branch router to be configured as part of the SD-WAN solution for the organization? How do we, for example, choose the optimal path for our traffic to go through from branch to branch? Well, we can do this by writing application policies, okay? And we can push those policies through the centralized controller and blast it out to all the edge routers if we wanted to. Viptela also offers cloud capabilities. Now, the reason we mention cloud capabilities is because we'll have a look at those components in a minute. We talked about the secure architecture, several components. Well, the cloud capabilities we're referring to are SaaS, software as a service, and infrastructure as a service, for example. Okay, so we can, if you've ever heard about the term cloud on the ramp, cloud on the ramp allows us to pool software, from Salesforce and Office 365, for example, and we can optimize the paths that we use so that the software can be delivered as if we were right there physically. You're bringing the cloud as close as possible to the end user, if we put it that way. So there are several things that Viptela offers that is attractive to the Cisco SD-WAN solution, and we're going to have a look at those, but mainly focusing on the secure architecture and try to explain the fabric operation, the application policies, and the cloud capabilities that we've been discussing so far. Okay, so what is this SD-WAN architecture? Well, remember there are 4 things we mentioned that we need to be aware of, okay? And we need to consider those 4 areas that we're interested in working with. If I could just back up a little bit. I'm just going to back up a little bit to my previous slide. I think it's important that you highlight those 4 things because I think we want to work from there. So I just let the slide get back to where it was previously. So let's back up and get that particular visualized solution. So we can get that upcoming quickly. Just bear with me a second. I'm just trying to realign my slide. That's what happens when you have these timers in place. You would often have to go through a bunch of states to be able to get to that point. So hopefully now we should be able to move as quick as possible. And what I wanted to show you was those 4 areas that I just highlighted before we have a look at, that architecture that we mentioned just now. Let's get this moving back as it should be. If you could just bear with me a second, we should get that there. So yes, we were talking about the 4 areas that Viptela solution gives us. We talked about secure architecture, fabric operation, application policies, and cloud capabilities. Now that's important to us. The architecture, the fabric operation, the policies, and the cloud capabilities. The architecture are the components. The fabric operation is how we deploy that fabric as an overlay, and the application policies is how we control the network by pushing configurations, instructions through the controller and blasting it out to devices. And the cloud capabilities are using those cloud services like software as a service and infrastructure as a service. Okay, so we mentioned that in the previous slide, and we wanted to have a look at the secure architecture. That was the first point we talked about. Now, in the secure architecture, there are 4 key areas. Now, the 4 key areas are management, orchestration plane. So the management and the orchestration plane live in one block, as you can see from this slide here. While the control plane is in a single block and the data plane in a separate block. Let us start with the management and orchestration plane. Let us start with orchestration first. At the orchestration plane, we use a component of the SD-WAN architecture that is called vBond. vBond allows us to orchestrate and provision. What does orchestration mean? Well, if a network device, a router, is coming onto an SDN network, it has to be identified, it has to be authenticated, and it has to be provisioned on the network. So orchestration allows us to identify the router and onboard that router on the network. So vBond allows us to orchestrate all the different devices that are going to be coming on the SDN network. That is the first point of contact. So orchestration plane, we use vBond. Cisco Viptela uses an appliance called vBond. To do management, we use an appliance called vManage. Now, after the orchestration, after a device has been identified through vBond, the next thing it needs to talk to is vManage. It has to be managed. Well, what sort of management does this device need? Well, this device is going to need some initial configuration, right? It's going to need the initial appliance configuration that has been created by the organization itself. Okay, so vManage pushes all of that data to the device. Now, in the control plane, that is the brain of the network. Now, remember the idea of SDN was to extract the control plane from the hardware itself, from the box, and store that remotely. Well, that's what vSmart does. So vSmart is an appliance that is part of the Viptela SD-WAN solution for Cisco that allows controlling of the rest of the devices in the network. So the vSmart controller works in the control plane. Now, so the device has been orchestrated by vBond, meaning it's been identified. The device has been vManaged. It's been in touch with a vManage appliance. The initial configuration has been pushed onto the device. And the next point will be to talk to the controller, vSmart. So the vSmart appliance within the Cisco SD-WAN Viptela provisioning allows that to take place. Now, at the vSmart, it means we can, At the vSmart, it means we can push a whole new bunch of instructions and configurations to that edge device. What about all the routing, the OSPF, the EIGRP, the policies that have been written can now be pushed through the vSmart controller to the edge device. Now, that communication between the controller and those edge devices has to be secure. So there's a protocol, a special type of protocol that is used by the edge device to talk to the vSmart controller, and that is OMP, your overlay management protocol. That is encrypted data. So that controller is able to communicate effectively with the edge device. And finally, at the data plane. Now, the data plane is where we find our hardware, possibly, but it's not just hardware, because in the SD-WAN environment, we can leverage virtualization, right? We can leverage virtualization and have virtual routers, virtual switches, virtual firewalls. Now, all of those would exist at the data plane. So at the data plane, we've got that scenario where we've got our devices, our edge routers that are going to be positioned in our premises, maybe from one branch to another branch. We've got those Cisco edge routers in place. So let us go through this and think about what we just broke down in the SD-WAN architecture for Viptela. There are 4 areas. There's management, there's orchestration, there's control, and there's data. We need to be able to manage our devices, and vManage offers a wonderful, wonderful user interface. It is lovely. It's a beautiful interface to work with, and hopefully we get to see a demo of that pretty soon. So vManage interface is extremely attractive. It's a graphical user interface. GUIs are easier to use than CLI. So we've got a graphical user interface on vManage. We've got vBond, the orchestration, and vSmart. But what is important to be aware of is that 4 of these components need to work together to provide the secure access that we need. These components of the SD-WAN Viptela architecture are only as good as the underlying infrastructure. If the underlying network is not good enough, then we're not going to be able to leverage the underlying network to use vBond, vManage, vSmart, and of course, vEdges is the hardware, okay? So they're only as good as the underlay network. The overlay is only as good as the underlay. Let us think about that for a second. Now, let us jump in deeper and have a look at the Cisco WAN architecture. Let us see how the modules communicate. Here is a representation of a multi-tenant environment where there are different processes running, sharing resources, and how does all of this fit in with the SD-WAN Viptela architecture? Well, let us think back to our 4 components. We need vManage to be able to manage the devices. We need vSmart as a controller to be able to control the devices and push configuration down to those edge routers. We need vEdge, that is our hardware. It could be either virtual routers, or we could have some real gear in place. Those are the routers we need at a data plane. And of course, we need vBond to orchestrate. So let us try to make some sense of this thing we've got here, this visualization we have. We're looking at a scenario where we have a data center. We've got a campus network. Let me see if I can grab a pen here to annotate this, to make life a lot easier so you get to see what sort of things we're doing here. This pen can get tricky sometimes. So I've got a red one. And hopefully, oh, great. So you get to see. So I can undo that. Oh, that's even better. Okay, so now we have a data center here. Okay, and we have another data center to the right here. We've got a campus network, got a branch, and a small office. Now, let us start with, let's have a look at the 4 components on the left, and let us see how a router, a vEdge router, at a branch office or a small office right here. That's a vEdge router right here. We can see just above here. We can see that device. That's a vEdge router. That's another vEdge router over here, and another vEdge router over here, and another vEdge router over here. So this is an SDN enabled network, an SD-WAN network. Now, it is important to understand, and I think I must highlight this, is that the 3 components, vManage, vSmart, and vEdge, could be in the cloud. Software, vManage, vSmart, and vEdge could live in the cloud right here, as you can see. Okay. No, wrong. I should say vBond. That's what I meant to say. vManage, vSmart, and vBond could be in the cloud, or could be on premises if we wanted to. Software-based. However, hardware could be our vEdge routers, or also software. So we've got in this diagram, we've got the vManage in the cloud, we've got the vSmart controllers in the cloud, and we've also got the vBond in the cloud. But the vEdges are at the locations, the data center, the small office, the branch, the campus, and so on. So here is let us see how this process runs. If we can clear some real estate on this screen first. Okay, so let us see how this process runs. So here I have a device right here. This is a vEdge router. This vEdge router is at a small office. That could be my home. You get one of those routers that are capable of doing what it needs to do. Special routers that allow SD-WAN to run. So I've got my vEdge router. My vEdge router is on an existing transport network. Where is the existing transport network? You might have MPLS, 4G network, or an internet connection. Okay, there are all several transport networks that we use on the WAN, right? MPLS we mentioned as one of them. Even DMVPN could be there as well. Okay, that's my transport network. That's my underlay network. But you know, this branch, this small office that I am in, we've just bought a new vEdge router. Okay, and this vEdge router will be used to connect to the SD-WAN network. I want to take advantage of all those things we looked at, centralized application management and the rest of it, improve security and reliability. So I locate my vEdge router in my small office. I've got an existing underlay network, because without an underlay network, you're not going to run any overlay on top of it. So my underlay network could be MPLS. You know, I could be using an internet connection, DMVPN across to my data center or to the campus itself. But we've purchased a vEdge router. So the first thing that happens is as soon as you connect your vEdge router, to the internet, it's going to call Cisco. It's going to call back. It's going to call Cisco. And when it calls Cisco, Cisco is going to know that, look, we've got a new fabric, a new router, a vEdge router that has got the SDN fabric on it, meaning it's got the iOS that allows SDN to be integrated with this device. Well, at Cisco's, they're going to know who the customer is because of the details for purchasing the device, and they're going to know what sort of networks you're already running. So with a PMP plug and play at the Cisco end, that device is accepted. It's onboarded, right? Now, when it's onboarded, the first thing that needs to happen is this device here. I'll write it up here. This device here has to talk to vBond. The first thing to talk to is vBond, because vBond has to identify the vEdge router. It has to be sure that the router has all the parameters in place to join the SD-WAN network. So vBond does this thing. It checks the identity of the router and authenticates it. And the next thing that happens is the device has to talk to vManage over here. Now, what does vManage do? vManage has to push down the original configuration that needs to be applied to the device, okay? The router, the vEdge router. So that configuration is applied to the device and it is ready to talk to the vSmart controller over here. So talking to the vSmart controller simply means all the routing protocols, the OSPFs, the EIGRPs, the RIPs, the STPs, the control information will be able to move across, and that configuration could be applied to the vEdge router itself. So right now, the router has been orchestrated by vBond. It has been initially configured by vManage, and now it has vSmart controller talking to it so that we can dynamically push our instructions and policies to the vEdge router. It's also important to know that the vBond orchestration would also, or rather the vBond orchestration would also pull telemetry from the actual vEdge router itself. It needs some analytics, needs some data to be able to have a look at how that device is performing. So you can see that communication taking place. Now, of course, at the data center, we've got similar things going on with vEdge routers. All of these vEdge routers would announce themselves to the vBond for the orchestrator initially, and then vManage, and then the controllers. Now, when that happens successfully, it means a vEdge router is able to talk to another vEdge router directly, just like this. And if you notice all these paths in there where it says SD-WAN fabric, those are secure IPsec tunnels. It means you can create multiple dynamic secure IPsec tunnels to be able to communicate with any data center, any branch, any campus that has a vEdge router in place. Now, you're possibly thinking, what sort of vEdge routers could I use in this environment here? Well, let us get out of this first. Let's undo this and now have a look and see. Get back to our pointer. Okay, so if we look just below, some of these points coming up just now, we can see when we're looking at the data plane, there are several flavors of vEdge routers that are available. The ISR's 1000, the 4000 series routers, and the ASR's 1000 series routers as well. Okay, those vEdge routers are virtual routers. Those are running on a Viptela operating system. You can have those in a GNSP environment, for example, if you've got the OSes to implant on the appliances. We've also got Edge Router software platform. So we've got a hardware platform that are different from the software platform I meant to say. The CSRs are the virtual routers, which are the software platform, and the vEdge routers are the hardware platform. So the 1000 series to 4000 series are used there, while virtual platforms, we've got a CSR cloud routers, cloud service routers, 1000 V series are used. And we've got quite a few of that as well. So I've got some of those running on my GNS3 platform environment that allows me to integrate SD-WAN as well. Okay, so let's get rid of all of this on my screen. Okay, so there is a demo that I would like you to access. I hope that demo is live. It's available, and you might not need to access it right now, but there will be in my slides. Now, Cisco has a live demo available. Some of you might be aware of this if you've looked into SD-WAN already. Cisco has a live demo of SD-WAN in a lab. Of course, it's a lab-based demo that is hosted in the cloud, and it is free to access. Okay, so you can go to cisco.com, SD-WANs in that link, and when you get to that page, there is you can download a document to review before you access the SD-WAN demo. What you're accessing, remember the 4 components we talked about in SD-WAN. We've got a management appliance, which is vManage, right? And we've also got vBond for orchestration, and we've got the vEdge routers themselves. But what we're interested in doing, and vSmart controller, what we're interested in doing is imagine the network has already been set up, okay? Meaning vBond has orchestrated the device, vManage has applied the initial configuration and provisioning for that device, and the controller has been able to blast the routine configurations or dynamic configuration instructions that are required on the device, and the device is ready. So how do you manage the device? Well, you're going to use vManage. So Cisco gives us a free live demo lab platform that you can access vManage on. Okay, vManage is going to be able to look at every SD-WAN enabled component, and to be able to access that, you can just use a username of demo and demo 1, 2, 3, 4. Now, just before we break up for 15 minutes, I did say it'd be nice to break up at 10:30. I think it was, I said, probably 10:30, I think I said. Well, let us aim for 10:30. So if we break up at 10:30, then we come back at 10:45 and finish off the rest of the session. But have a look at this. Just before we break off, I want to try and see if our demo is live. So just bear with me on this one. Just going to escape on that one. Let's go to that demo. That is a GNS3 solution that I built. Okay, so where is that demo gone? I think I've got Google Chrome running somewhere. Let's get Google Chrome. I think it works better with Google Chrome, as they say. I hope you can still see my screen because I've shared my entire screen. If you can't, please let me know. On the screen, we are at a Cisco SD-WAN live demo. It's a platform that is worth using because you get to appreciate how you can use a central controller to manage, or rather, you can use a vManage dashboard to be able to write applications and push those applications down to the centralized controller vBond and blast those out to the devices themselves. So this is a really cool feature that you might want to play around with. So when you land on this page, you expect it to have a Cisco account. If you don't have one, please create one. It is pretty free. It's free to create, no charges. And I've got a Cisco account. You would imagine I do. So I'm logged onto my Cisco account now. And what I want to do is download the demo guide. Now, in the demo guide, there's quite a few things that are useful that you want to have a look at. So I think I've got the demo guide open in a separate window somewhere, if I can find it. Oh, yeah. So there we go. There is my demo guide. So I clicked on the demo guide previously, and what we're looking at is, some sort of set of instructions on how to use the demo and the sort of features that will be attractive to you. And in this particular demo guide, of course, you've got the login details that are present as well. It really gives you a granular view of the of the vManage software. Like I said, it's a wonderful, intuitive platform. It gives you an idea of the health of your network. It shows you a breakdown of your WAN connectivity and gives you a warning on the sort of connectivity you have in terms of the WAN edge health, your devices at the edge. Remember those vEdge routers we're talking about? Those are the devices that are going to receive configuration from the vSmart controller out there in the cloud and so on. And you get to see your centralized policies. Remember we talked about creating policies and pushing those policies out to all the vEdge routers and so on. And of course, here is an example of how the data prefix is used. So for example, here we're specifying the information that is necessary on a particular device, for example, IP addresses that will be used in that device. And there are quite a few things, as you can see, that could be done right underneath that category. There's also site information about your hardware, where they're located, and also virtual devices as well could be looked at. You can set up some new SLAs, some service levels agreement at the management platform. All of those things that we can normally do. These are what ISPs would normally do, for example. So an ISP would be responsible for managing quite a few VRFs, some virtual routing forwarders of different customers. Because imagine an ISP has two edge routers to take care of 1,000 customers. Well, we know there's a main routing table on a router. Well, what an ISP is going to use VRFs to create virtual routing forwarders or virtual routing tables of all those customers. Now, life is extremely difficult with the ISP. So what SD-WAN provides is to be able to do more with less. And blasting using this vManage center, we can talk to the controller that communicates with all those edge devices to deliver the sort of service levels that we hope to achieve. VPN connectivity can be easily provisioned between edge devices, as you can see. And here are some examples of the applications that could be used in that environment as well. Of course, we're aware that most applications that run on network platforms would be ported across these overlay technology. So there's quite a few things, or quite a bit to look at in your own time. Please feel free to have a look at this and play with this and try to use that demo. So back to my Google Chrome, it's 1018. Let me just see if the connection is up. So I'm going to click on that to access the SD-WAN. It's been on and off. Sometimes due to network traffic, you get problems. Oh, there you go. We've got a 503 error, dcloud demo content unavailable. That's what happens when you use free things. They can always throw you off sometimes, but never mind. There are other ways we can do this demo. Remember I talked about open software, Open Network Foundation. In the Open Network Foundation, we can use, free tools, that we can download onto our systems and to be able to apply the configuration we require. Well, having said that, we're not able to access the demo. However, we can see in this slide over here that when you access the demo, you would be able to see the Cisco vManage appliance. Now, this appliance allows us to manage our network and to be able to monitor the network itself properly and deploy some new instructions through the controller down south to the edge devices, okay? So in your own time, when you get the opportunity, if it comes back up, it'll be nice for you to play around with this vManage dashboard and interact with it as much as you can. Now, just before we break off for a little tea break, I think it'd be nice to break up now as this demo hasn't functioned, because I'll have to have a look at a slightly different demo and then we can do something different. Now, remember I talked about software as a service, providing, Office 365, for example. Software as a service is extremely attractive because of the total cost of ownership, right? So a small business can operate very easily without purchasing expensive software. Well, likewise, we might not necessarily need to purchase expensive hardware. So we can have an infrastructure as a service. We can use Google Compute, for example. Google Compute is a great place to play around because lately, or not lately, well, I'll say a few months back, I've been playing around with Google Compute. Google Compute is similar to what, the offerings by Microsoft Azure, the offerings by other IaaS providers. AWS, for example, offers you infrastructure as a service. You can hire some servers to run some computation for you. But with SD-WAN, software as a service and infrastructure as a service comes right to the edge of your V-Edge device. Because imagine if you were going to use infrastructure as a service. Well, using infrastructure as a service means you're relying on a CPU on the cloud that you're renting, the power of the processor that you want to use. Google has got some fantastic processors that are able to run the sort of instructions that you require to execute to be able to decrypt some really, really complex algorithms with 256-bit keys, maybe. Well, think about that. High performance in the cloud. How do you deliver that high performance to your location? Well, bandwidth is an issue, right? So edge computing takes over. So remember, you've got your V-Edge router right at the boundary of your organization. Well, that V-Edge router is capable of connecting to an SD-WAN network. And if you remember, the SD-WAN network allows us to have, very dynamic IPsec routes from where we want to get to. Well, that brings a lot more efficiency. So the infrastructure as a service and software as a service are going to be talking to your network like they're just within your network. So you experience less latency, less delays that you normally have with cloud services. So it's worth having a look at Cisco SD-WAN, cloud on ramp, being able to use SES and software as a service and infrastructure as a service. Okay, I think it is a good time to break off because, the throat gets really dry, and I'm sure you would appreciate from experience, that'd be nice for us to maybe get some liquid and we can get back here if I may say. It's now 10:24. I will give us can we get back here, I would say at 10. Let's make it 10:40. 10:40, we get back here. So we got roughly just under 20 minutes. So I'm going to break off at this point, but before we break off, I hope we're all back to our stations and ready to go for the second part of this presentation on SD-WAN and SDN technology. So I'm just going to expand that screen and let's do this first, minimize that first. And then we can get a full expansion. Let's drop that down here. Okay, so I hope you can all see my screen again, and we're back on to where we left off. Now, if you can't hear me, please, or you can't hear, just let me know, but I'm hoping everybody's on board. Okay, so we've had a little break and we're ready to go for the second part here. Now, let us backtrack a little bit to where this all started. We started looking at SDN, the software-defined networking paradigm. And what we understand with SDN so far is that it's a concept that introduces programmability into the network. Because if you're trying to automate systems and you're trying to coordinate a large number of groups of individual devices, it'll be so much easier to automate the configuration and the management of those devices. And we've seen from SDN, there are huge, huge benefits. The benefits of giving us mobility. So, what we get with SDN is users would always be mobile. Mobile users would often move from one network to another. And in the process of moving from one network to another, you would lose an IP address and get a new IP address and so on. All of that adds issues with performance as well as freedom of movement, like we would like across our networks. So what SDN gives us is a seamless environment that allows us to move freely without worrying so much about losing our IP addresses and getting a new one. It also avoids all the errors that we've been talking about. And we mentioned in SDN, there are two flavors, two areas we need to be concentrating on. You know, the external network, which is the WAN. We've looked at SD-WAN. And also there is the internal network, which is SD access. So we're going to be focusing on SD access just now. And let us dive in and see exactly what SD access is. Okay, so we mentioned how traditional networks are problematic. You know, traditional networks are slow and they are prone to a lot of errors. And we know that the configuration of a traditional network takes away the dynamism that we need in today's networks. Today's networks are responsible for driving IoT connectivity, as we know how problematic that could be, connecting all sorts of things to the internet. There's more demand for bandwidth, there's more demand for configuration, and there's more demand for that flexibility. And in the slide we're looking at here, it is easy to get an overview, though these records are old, as far back as 2016, but I can bet you that the shift hasn't moved much. You know, if you look at the ratio of operating expenditure to the capital expenditure layout, the operating expenditure has gone much higher than the capital expenditure. And that's a problem that we all have to deal with. And what you and I know, if you've ever been in a networking environment or experienced network issues, you would notice that, you know, network administrators are often faced with the difficulty of handling multiple traffic from different sources. They're heading in different directions, always changing. So OPEX compared to CAPEX, you know, much higher, okay? So there's a lot of labor-intensive work going on into the management and operation of network. And if we look at the breakdown of that 3-to-1 ratio on what makes our OPEX so high, operating expenditure, well, 95% of the time we are performing network changes, okay? And those changes are often performed manually with a number of tools. And we can see that we're spending a lot of our time doing network maintenance and network troubleshooting. 75% of the time, you know, we operating, doing a lot of troubleshooting, as we mentioned, network changes 95%, and then manual configuration of that and troubleshooting as well. That's quite high. 70% of the time, policy violations happen often. And we talked about the human being the problem. Let us backtrack a bit. I think it is safe to say that SDN solves the problem that humans introduce into networks. We are the weakest link. A lot of errors, manual configuration leads to a lot of policy violations, okay? And we want to avoid that human error. And we also want to reduce the problems we have where the demarcation point stops and so on, okay? So there's so many things that SDN with automation and virtualization, you know, and segmentation, we could benefit from. So that's why we need SD access. Remember, SD access works within the enterprise. It works within your LAN. We look at how we operate the network apart from the traditional platform that we use. We're looking to improve mobility. We're looking to improve dynamism of getting up new branches and getting up new devices. You know, we're looking to improve performance overall, okay? And that's why SD access has been defined as a substitute, not so much a substitute, but an add-on to your existing traditional platform that runs in your enterprise. So SD access for the enterprise, SD-WAN for the wide area network. They're similar things, they use similar concepts, but with the internal network on the enterprise, we start looking at technologies like VXLAN. Now, VXLAN is your virtual extensible LAN, okay? You know, we got to mention those especially. We got to look at the Lisp protocol as well that is used. So we're gonna look at some of those overlay technology that are used in SD access, because what we're trying to do with SDN is overlay on top of the traditional network. Okay, so those are those challenges we were talking about: manual configuration, slow, error prone. You know, and we really need to take care of these issues. They introduce a whole lot of problems into our traditional networks, and SDN promises to take care of all of that for us. Okay, now SDN doesn't solve all your problems. It provides the tools to solve your problems. Does it improve the end user experience? Well, there's a lot of research going on in that area on how to leverage SDN to improve SDN experience. Well, imagine what's been going on in networks today. You know, a lot of bandwidth intensive applications like video on demand and real-time video and all the rest, streaming data. You know, that takes a whole lot of demand on the network itself. You know, can SDN play a huge part? Obviously, you know, because we've seen that we're able to sort of create these dynamic paths to destination using a secure channel to be able to exchange data in a safe and highly performable environment. Okay, so let us dive deep into SD access and look at some of those advantages that we've mentioned with SD-WAN as well. Okay, so here are a number of things that I want us to be aware of. And these are some of the advantages with SD access. Now, SD access is at the enterprise level. So we are going to leverage some of the benefits of network automation we talked about. Okay, we can automate our processes internally if we wanted to by writing, I don't know, a Python script, for example. We'll talk about that in a minute. By writing a Python script and pushing that Python script to a controller, and that controller is able to apply the configuration and push them out to all the devices that are part of the network. Network assurance and network analytics, those are important. The reliability of that network, does it deliver what it says it needs to deliver? In that way, we must monitor the network. We must monitor the network and look at the telemetry of the network, and to be able to use that to derive the sort of network assurance that we need. Host mobility, you know, a host is able to move around from one end to another without needing a new IP address. And we've seen in networking, you know, if I left my home network and went elsewhere, I would need a new IP address. Well, that's a problem. So we want mobility freedom. You know, we want a scenario where the host is able to move from one location to another without having to change their ID, without having to change a new IP address. Identity service are great. SD Access uses an identity service that is already in existence. It's going to leverage the ISC, Cisco Secure Identity Server, okay, to be able to authenticate users. Now, the case of authentication is different. Now, let's think about how we get authenticated in some cases. You know, we get authenticated based on identity of individuals, but that individual could be part of a group, for example. Okay, so the Cisco ISC Identity Service Engine allows us to do group-based policy and segmentation. Now, group-based policies are easier to enforce than individual policies. So we're going to look at the ISC's Identity Service Engine and how it does that. Policy enforcement, you know, we can obviously apply policies to different parts of the enterprise, okay? That is easy to do with SD Access because we've got a single controller that allows us to control the different parts of our enterprise network. And in that way, policy enforcement is a lot more secure, a lot more effective, quicker, and granular. Okay, so we get a lot of benefits with the SD Access compared to our traditional enterprise networks. Secure segmentation, yes, we can provide segmentation through SD-WAN. You know, the various areas of our enterprise network, such as our data center within our enterprise network or our management centers, those could be secured quite easily by using OMP. Remember, we talked about the OMP protocol that goes through from our controller down to the vEdge device. What about virtualization? Well, that's pretty obvious. You know, we're able to virtualize our hardware and to be able to have multiple devices, virtual devices around our network. So these are just some of the advantages of using SD access in place of our traditional campus network. Now, let me take you back a little bit. We talked about several things in SD-WAN. We talked about the architecture of SD-WAN, making use of 4 components. For management, we use the vManage, right? For orchestration, we use vBond. For controlling our devices externally from a central point, we use the vSmart. And of course, our devices that are distributed around our locations are the vEdge devices. Now, when you have a look at SD access, software-defined access, well, it's going to use a similar architecture, very similar, because if you look at this particular thing here called the Cisco DNA Center, well, the Cisco DNA Center is a replica of the vManage. Now, think about what the vManage does. The vManage allows me to do things like, you know, create new policies, to be able to push configuration down to my edge devices, to provide assurance. Well, that rings a bell. If you look at the Cisco DNA Center, what that does, similar things to the vManage component of the SD-WAN architecture. So with the Cisco DNA Center, we expect to find things like, remember, virtualize. We can find our DNA Center, our vBond, our orchestrator, all right, and our vManage. Now, we can also have a vSmart controller as well, as we mentioned in SD-WAN, okay? So this is just an idea of how we could use software-defined access in our local area network, in our enterprises, within our organizations before we get to the outside world. So the technology has been developed to allow us to have internal networks as well as external network. So what is SD access? Now, there are 2 components of SD access, right? And these 2 components should be obvious to us in some point. Now, the reason I use the word obvious is if you have a look at this visual to my right-hand side here, the main 2 components of SD access are the campus fabric. What does that sound like? Overlay. Now, a fabric is software. A fabric is overlay sitting on top of an underlay network. So the fabric is a program, is an interface, or rather an application that has been programmed to allow your network to take advantage of the existing campus network. Okay, so for example, when you execute a VPN connection from one end to another, that is a fabric that is going to make use of the underlay network. So what is SD access? SD access is the campus fabric that is managed by the Cisco DNA Center. And what is the Cisco DNA Center? Well, it contains things like vBond for orchestration, vManage to be able to manage the devices, vSmart to be able to control things, okay? So the Cisco DNA Center is your management point that allows you to do things like design your network, provision new devices, apply some policies, and provide that much needed network assurance for analytics that is needed, as well as reliability on your network. Okay, so that's the idea of SD access. Now, let us dive deeper and see some of the components within the architecture of SD access. Now, in this architecture, we can see, I just move this a little bit, actually lose, let's drop that down here, just bear with me. Okay, I tend to, okay, we get that back. Okay, so back to where we were. So what do we expect to find, with a Cisco SD-Access architecture? There are four basic layers, as you can see. The slide does what it was. I think I need to stop that timer. Seems to have a mind of his own, trying to get quicker than I am. Anyway, back to what we're talking about. Oh, it does. I beg your pardon. I think I should really stop my timer before please bear with me. The technicalities we experience sometimes. Okay, back where we should be. And I hope it stops at this point now. Made a little adjustment. Oh, pardon me, I'm going to get there at some point. Okay, so now we should stop. Okay, that stops their fingers. Okay, that stopped. Okay, so what we're looking at is the SD-Access architecture. Now, this kind of reminds me of the SD-WAN components that we're looking at. Now, in this SD-Access architecture, if you have a look at the Cisco DNA Center, that lives in the management layer. Now, that reminds me of what we talked about with vManage. Okay, with vManage, we were able to manage our devices remotely. And if you look at the control layer, we've also got part of the DNS Center using the network control platform and the network data platform. Now, the DNS Center and the control layer really looks at how we apply the controller to all our devices at the physical layer, for example, and that's where all our vEdge devices are, okay? The vEdge switches and the vEdge routers and firewall and all sorts of things that we need to use, right? And within that control layer, we use the IC, the Cisco's Identity Service Engine for what? Authentication. Now remember, SD-Access allows us to do group policy authentication rather than individual authentication because it's a lot easier to manage users in groups. Well, we leverage the Cisco Identity Service Engine that uses group policies, okay? So in that way, we can authenticate users based on group policies rather than individual IDs. Now, at the network layer, recall we have an overlay network and an underlay network. Well, we know what the underlay network, that's our current transport network that we have set up. Well, on top of that, we're going to build an overlay network with software, right? And that overlay network is going to use some special protocols that allows us to extend, for example, our LAN. So VXLAN, virtual extensible LAN. You know the problems with extending LANs from end to end in a network. Well, we lose the functionality of layer 2. Okay, VLANs operate at layer 2, so we lose that functionality when we're trying to exit one subnet and go into another. Yes, we can have end-to-end VLANs, but we know the problems with that. So with a VXLAN, virtual extensible LAN, we overcome that problem as well. Okay, Lisp is another protocol that is used. Lisp is your location identity separation protocol that allows us to separate the IP address that is used by a user to connect to a network. Rather than using an IP address, let us have a look at a different value, and that value you would take with you everywhere you go, across different networks, meaning you don't need a new IP address every time, okay? So these four layers are important to us because we need to understand how the Cisco, how the SD-Access architecture uses the Cisco DNA Center to be able to manage our Cisco SD-Access network, in this case, within our enterprise. Okay, so what is this relationship we've been talking about of overlay to underlay? Let us see if we can visualize that. In this slide, we've got an overlay network that maps onto an underlay network. So imagine I was building an SDN network or an SD-Access network within my enterprise. Well, below in the underlay network, we can see there are multiple paths to get from one endpoint to another. going through a number of routers and switches, in this case, multi-layer switches that act similar to routers, right? We can see that data traverses the different paths, and what happens is each intermediate device, such as routers and switches, will have to do their thing. Have a look at the IP address, determine if it's in the routing table destination. If it is, let it on its way. If it's not, I'm going to drop it, and so on. Well, that identification process takes a long time, having to traverse all of this path. So the easy thing to do would be to have an overlay network just on top of the underlay. The overlay network, as you can see, allows us to build secure tunnels directly from one endpoint to another, right? In that way, you overcome the processing that is done by the intermediate devices en route to its destination. And these are not rigid, these are not static. These VPN, or rather these overlay connections, are very dynamic, as you've seen. I can spin off those connections to any endpoint. But for that to be possible, your edge devices have got to be speaking SD access language, okay, in this particular case. So it's important to understand the mapping of the overlay to the underlay. The overlay is only as good as the underlay, okay? So that's important. And if you remember from the previous slide, the overlay protocol is going to use, protocols that are more sophisticated than we use in the underlay. Protocols like Lisp, for example, location independent separation protocol to avoid carrying an IP address with you, use a separate identity, and VXLAN to be able to extend those LANs in our enterprise network. So what is this SD access fabric? Now, fabric is a key word that we've been throwing around lately, and fabric is essential software, okay? So if you, for example, take a router, let's say you take a 1941 router, which is a slightly older router, which is not a traditional SD access router, because our existing routers are capable of SD access. You just need to put a new fabric on it. You just need to put a new iOS on it, an iOS that is able to deal with SD access or SD-WAN, right? So we've got some old 1941 routers in my lab, and what we've done with some of them is to overlay that with SD-WAN, SD access technology. Now, Cisco offers the iOS for those who have got customer accounts. You can overlay a 1941 with an iOS that allows SD access to work. Now, let us go back to the SD access fabric. We do things in different planes. As in networking, we know that it is easier to work with different planes because I can change things at a certain plane without worrying about what's going in the plane above. So SD access uses 3 planes. The control plane, as we know about, the control plane is where the brain is of any device, okay, with respect to networking. So our routers and switches would have a control plane. They will also have a data plane. Now, before we get to the policy plane, let us look at the control plane and how SD access uses that control plane. Well, at the control plane, that's where our configuration is done, right? That's where we do things like OSPF and EIGRP. That's where we execute some of the control information that is needed for our networks to operate properly. Well, what SD access is saying is, I'm not going to use the traditional method in the control plane. I'm not going to identify end devices, or rather users, by IP addresses. I'm going to identify those using Lisp, location independent separation protocol. Well, I think the technology is in the name. Location independent, meaning you can be anywhere and still be connected, right? You could be anywhere and use the same ID, but we can't do that currently with our IP addresses. As we move from campus to campus, we got to chop and change IP addresses. That introduces a whole new problem introduces problems in performance. So to alleviate that problem, let us use a protocol. Lisp has been around for a while, so SD access just really leverages existing technology. So to alleviate that problem, we can use a protocol that focuses on the user, that focuses on the user's ID rather than the IP address that they use. So in that way, you can move around and be identified based on your ID without being identified based on the IP address. We'll see how Lisp operates in a minute. Control plane has a simplified routing process because of the SDN SD accessibility that we've talked about, where tunnels are created between endpoints. What about the data plane? Now, the data plane is where the heavy lifting is done, right? That is where we find our application-specific integrated circuits. Those circuits are necessary because we want to be able to switch packets across the network. Well, at the data plane, a lot of things go on at the switch. Some of the things that we experience is how to move, extend our VLANs, for example, across our enterprise. Well, here comes VXLAN tunneling protocol. VXLAN, the virtual extensible LAN tunneling protocol, allows us to tunnel from one subnet to another in a secure way, okay? What about the policy plane? Well, remember Cisco SD Access Fabric is going to use the identity service engine, right? The identity service engine has been around for a while. So what that allows us to do is to apply our policies based on Cisco TrustSec. And that's been around as well, CTS. Cisco TrustSec allows us to use the identity engine, ISE. And then rather than identifying individuals based on individual settings, we can use security settings that are based on groups. So group access rather than individual access. SD access is going to leverage all of these to be able to function properly. So what are the components that we would find in SD access? What are the roles they play? There's quite a few things going on here in this SD access network, and we're going to try to make some sense to try to demystify all of this, okay? You can see some notes to the left of the visual, giving us a breakdown of the several devices that we have in our diagram. Have a look at that diagram closely. Now, if you've been in networking for a while, or if you've just got into networking, you might have noticed that networks are built on a 3-layer architecture, right? The access layer, the distribution layer, and the control layer. It is important to understand that each of those layers play a significant part in the network. So here we're looking at an SD access network that has devices playing different roles. And we're going to have a look at some of those devices and see what roles they play that are significant to the things we want to achieve in SD access. In this particular diagram, right at the bottom of the diagram, we've got a number of fabric edge nodes. Fabric edge nodes are access layer switches. Now, if you've ever worked with access layer switches, those are the switches that allow users like you and I to connect to the network. So for example, if I was at university now and I was using a network, I would be connected to, physical connection, for example. I would be on a desktop, I would be connected to an access layer switch that is in a room within the building somewhere, okay? And that access layer switch could become a fabric edge node, okay? So the switch has to be capable of SD access. It is the edge of our fabric. It is the edge of our SD access network. So that switch at the access layer has to be capable. Now, don't go chucking your old boxes of 2960s away or your 3000 series switches away, because guess what? You can download some iOS to be able to use it as a fabric edge node, fabric edge node, okay? So it's important not to chuck those old boxes away because you just need a different iOS to get it working as a fabric edge device. Now, the fabric edge device is an important part of the SD access fabric. It has to be enabled for connectivity to allow our end devices to get through. Just above of the fabric edge node, we've got the fabric intermediate nodes. Now, the fabric intermediate nodes are a distribution layer within our network. Now, at the distribution layer, we expect to find some multi-layer switches, right? Some 4000 series switches in that place, or some 3000 layer switches, or 3000 switches, okay? So those switches at the distribution layer are more sophisticated than our access layer switches. They can do things like, policies, we can put some routing protocols on them like we do in traditional networks. But for the case of SD access, these particular distribution layer switches are referred to as fabric intermediate nodes. Okay, and what our fabric intermediate nodes do are exactly what they would do within our networks. Okay, sometimes they do not provide any sort of service, but they just simply allow us to provide some sort of distribution control at that point. Above our distribution layer, we've got our core devices. Now, at the core, you're going to get some more sophisticated hardware in place, right? I mean, you get things like high-level 8,000, 9,000 series switches, or we could use some 4,000 series switches as well, right? And the reason we use switches at the core better than routers is because of the multi-connection points that we have to be able to aggregate all of those connections at a single point. Those are fabric plane control nodes, okay? Now, that's ringing a bell. A fabric plane control node is a node that allows us to control our SD access network. That sounds already like what we could do with a controller, okay? So let's read about the control plane nodes. Well, remember we said we're going to avoid using IP addresses? Well, the control plane node contains a database. It contains a mapping of an endpoint to a location, EID to RLOC, it's called. So let us map the endpoint. What is the endpoint? Well, your device, my device, okay? My laptop. Well, my laptop lives at that location. I'm going to map my laptop to my location. And I'm going to map that into a database that I'm going to store centrally. And where am I going to store it? I'm going to store it in the fabric control plane node. Remember, control information, control plane, data plane. Well, my control plane has been moved to my control plane node. So I'm going to store that database mapping of EIDs. Oops, press the wrong one. Let's go back. So I'm going to map my database. I'm going to have a database of my endpoints to location. Now that gives me flexibility, right? It means I can go anywhere in the network, and that mapping is going to stay in the fabric control plane node. That gives me the mobility that I want without losing connectivity, right? Now, the fabric control plane node could also be a fabric border node, right? So yes, it could operate as a control plane node or as a border node, but we can just select one of those to operate as a control plane node. Or we might want to get both core switches operating as control plane node for redundancy, as we know. We do not want a single point of failure in our case, okay? So those fabric border nodes are doing something similar. All right, those fabric border nodes are going to allow the connectivity of networks that are not part of the SD access fabric. So for example, have a look at our data center just up there. In our data center, we've got a wireless controller living there. We've got an identity service engine right there. We've got a DNS center right there. Remember the DNS center? Great. The DNS center allows us to manage our SD access, if you remember. Okay, we need a DNS center to manage the fabric for us to have SD access. So there's going to be a DNS center server sitting somewhere in your server room. You're going to have a wireless controller also sitting there because we need a wireless controller to authenticate or to provide wireless connectivity to users using wireless systems. We also need an ISC server sitting there, an identity service engine, to be able to provide the identification we need on our end devices and users. So these are just some of the components, or rather most of the components of the SD fabric setup. It's important to be aware that the key thing here we're taking away from here is the fact that you can have mobility without picking up a new IP address. Rather than mapping your IP address to your gateway, as we all do, right? What does a router do? It will map your IP address to your gateway. That's what we know. That's what routers do. Okay, you're living off that router 1, and that's where you are. That's got an IP address. I'm going to push data off to router 1 because, you know, that's where you are living. That's your gateway. But the problem is as soon as I leave my network, I need a new IP address. And guess what happens? That needs to be mapped again in the routing table. Can you see the problem? Routing tables are always changing because we pick up new IP addresses, and those tables are becoming a lot more difficult to manage. Let us make life easier. Let us not use IP addresses. Let us use an EID, an endpoint to location mapping. So what is that EID value? Well, it's not going to be an IP address anymore. It has to be a new type of address that we can use to map to the location. And what that means, you don't need a new IP address when you move around, okay? The routing tables do not have to be repopulated every time. And that makes network performance a lot quicker with SD access. What about things wireless? What do we do with wireless communication, for example? Well, wireless communication should not be left out of SD-WAN deployment or SD access deployment. Well, have a look at this setup here. In this particular setup, to the left is the traditional wireless network. To the right is our SD access wireless network. How would you integrate that into your enterprise network? Well, it's simple. If you remember the previous slide, in our data center, we had a wireless controller right at the top there at our data center, right? Well, likewise, we've got a wireless controller in our data center in a traditional wireless network. And what we can see at the bottom is that users trying to access the network from the access layer, where we've got some access layer switches, which is the fabric edge of our network. Well, in a traditional network, what they will normally do is when you're trying to connect to a wireless controller, you're going to use a tunnel called a CAPWAP tunnel. It's a secure tunnel, right? So through that CAPWAP tunnel that is set up between your access, set up between the access point at the access layer and the WLC, that CAPWAP tunnel will be used to exchange data and control information, right? So every time we try to exchange data, look at what happens. Well, let me see if I can get a pen to make life a lot easier to annotate that. So look at what happens right here. So there's a device, would like to talk to this device on the right, right? So in a traditional network, the device on the left would connect to an access point just here, right? That access point is connected to the fabric edge node. Remember the fabric edge, but this is not our SD access. We're just looking at a traditional network. So in a traditional network without fabric edge nodes and all the rest of SD access components, well, my traditional device below here connects to an AP, talks to a wireless controller using control information, right? That tunnel is set up called a CAPWAP tunnel. The CAPWAP tunnel would also be used for data. So when the device has set up its CAPWAP tunnel and would want to talk to the device on the right, guess what happens? Data has to also traverse the same CAPWAP tunnel and come down to talk to the device. Painful, right? It has to backhaul, has to go all the way to the WLC at the top and come down to the other device, right? Because it uses the same CAPWAP tunnel for data and control information. Okay, so the red line allows us to initially authenticate with the WLC, the wireless controller, and we use the same tunnel, the blue line, to get through to the end device. That's not efficient, that's not optimal. But what SD access gives you to the right-hand side here, much better. Well, if you remember, we've got our fabric edge device sitting right here. Let's get a red pen so we can annotate that even better. So we've got a fabric edge device sitting, let's undo that first. We've got a fabric edge device sitting right here, okay? We've got a fabric AP access point. Now, this fabric AP is enabled for SD access. It's not your traditional one. It has to, it has to have the iOS that allows that to operate. And then guess what? At the top there, we've got our data center, wireless controller, ISC, DNS center. Okay, so what's the deal? Well, remember we had a CAPWAP tunnel that was set up between, this device and the WLC over here. Well, that CAPWAP tunnel is set up for only control information, like authentication, initiating a connection with the wireless controller. all connected. And then guess what happened? In the traditional network, we use the same CAPWAP tunnel to exchange data with the device on the right side. Well, we're not going to do that with SD access. Guess what we're going to do? Well, we're going to create a separate CAPWAP tunnel, I should say over here. We're going to create a second CAPWAP tunnel, as you can see. So a second CAPWAP tunnel is used to exchange data rather than using the same CAPWAP tunnel that was set up. What that gives us, everyone, is a wonderful feeling that we can talk directly from here, from this device here, to that device over here without going all the way to the WLC and back down again. This is the power of SD access in a wireless controller environment, to be able to leverage overlay technology on top of underlay and create these secure tunnels. So that tunnel is a VXLAN tunnel that is secure between both end devices communicating with themselves. So that's the wireless controller environment that I was referring to, and how we can deploy those. Okay, so let's see what we got here. I think I need to, I always had this problem with my annotation. For some reason, my machine seems to like to do its own thing. Let's blast that off very quickly. Okay, so now we can go back to my pointer. Pardon, if I can find it. My machine has decided to freeze. Bear with me. Okay. Okay, so we are through on this part of it. Now we're going to have a look at another aspect to this. I'm still trying to get rid of that. Okay. I'd like to do a demo at some point, so I think I'm going to jump off this presentation so that I can show you a demo of some sort. I'm going to have a look at that DNA center again to see if it's live now. But before we jump away to that demo, let us have a look at one more slide, I think, because we've got less than 40 minutes to go on this particular session here. Look, this is a slide that shows us the control layer. If you remember, with the Cisco SD access architecture, we had a control layer. There were 4 of them. And let us have a look at that control layer. Now, this is interesting from an SDN perspective because we get to see a bit more that's going on with the software-defined networking environment. Now, in this particular setup here, we've got a Cisco DNA center, and I think I need to annotate this one more time. So we've got a change that pen, I think will be great. Okay, so we've got our Cisco DNA center in a control plane. Now, remember, the control plane is where we want to be able to, do wonderful things like apply some automation and the rest of it coming from our DNA center, right? So over here, we've got an identity service engine here that does the authentication for us, okay? The policies that are based on group policies and so on. The DNA center, we can do things like provisioning, assurance, and policy application and design. Underneath of that, we've got the control plane right here, right? And just below that, we've got our devices. Well, here's the deal. With software-defined networking, we can use the DNA center and talk to the control center, right? Using APIs, application programmable interfaces. APIs are attractive. Remember, what we're trying to do is introduce programmability into the network. Well, we have to write some programs. We need APIs so that we can interface with the controller, right? Now, it's important to understand that the APIs are in different groups. Well, as all things going to the north, upwards, we've got northbound APIs. So the DNS center is going to use a northbound API to communicate with the network control platform, which is similar to the controller we've been talking about. And then the controller is going to push down the instructions that we've given it to the devices using the southbound API, going down south. And some of the protocols we could use in the southbound API are netconf, right? SNMP and SSH. We've also heard, we might have heard of a policy, a protocol called OpenFlow. Now, the reason I like OpenFlow is because one of my first implementations of SDN was using open software. So I had to use the OpenFlow to communicate down to my devices using the southbound APIs. So OpenFlow is one example that is pretty popular in the Open Network Foundation, and I advise you to have a look at that. So OpenFlow is one example. netconf is another example of a protocol that could be used in the southbound API to communicate. SNMP and SSH are some of those as well. Okay. It's also important to be aware of the northbound APIs that we could use. So if we're going to send instructions from the Cisco DNS Center down to the controller, well, the northbound API that we use for communication there could be things like REST. You know, if you ever heard about REST, the RESTful APIs, you know, REST is simply the ability to use HTTP, for example, you know, to use some of those great features in HTTP like put, get, and so on, okay? It means what we're trying to do is represent, you know, network parameters through those HTTP verbs like get, put, and delete, and the rest of them. And REST allows us to talk to the controller. Now, the question is, does the controller understand the representation of our data? No. If you go back to how data is represented on machines, you can think about SNMP in the old days. SNMP used things like OIDs, object identifications, to represent, you know, all the components in individual machines. That's very complex. So in this environment of SD access, well, the RESTful API, you know, talks to the controller, and that language is modeled or our data is represented and modeled in Yang. Yang is a modeling language that allows us to model our objects that REST is going to communicate with, okay? So these are just some buzzwords that are important with SDN and SD access and the rest of it. So we've got northbound APIs and southbound APIs. The protocols we use on the northbound are different from the protocols we use on the southbound. At the northbound, we're pushing configuration. We could also write a Python script. Yes, you and I could write a little Python script as an application for the DNS Center and push it down to the controller. In that way, we can automate the processes we want on the devices as well. Okay, there's a mention of AAA and Radius. If you've ever looked at a AAA architecture, you know, we use Radius protocol and TACACS to be able to authenticate users, and the Cisco ISC Identity Service Engine incorporates those two protocols, Radius and TACACS, into a single device as well. Okay, so if I could get out of this, I need to, the system seems to do its own thing when I'm not. Just bear with me again, it seems to have gotten stuck running a lot of processes at the same time. Okay, it's moved. I now need to escape that and undo all of these. That might be to manipulate my system a little bit to get all of this displayed for you. Okay, so I think I want to break off into a live demo, okay? Because as you would know, slides can be pretty boring. You know, having to read look at a whole lot of slides without some practical work, you know, it helps to break up the service. Okay, so I want to break off. The rest of the slides really just highlights, you know, some of the other features of the Cisco DNS Center, and it's worth looking at those. I will share my slides with you at the end of this session through the coordinator, and you receive the slides and you can often have a look at those again. Okay, so I'm going to break off this particular set of slides. I know you can read the rest yourself at a later stage. So in breaking off these slides, I'm going to now move to my DNS Center. Let us see if life's got better here. So I'm just going to refresh that. Well, as you can see, life's not good on the D cloud, right? So we're not able to have a look at the Cisco vManage that I promised, but look, I've got a substitute for you, okay? The substitute I've got for you is not Cisco SD Manage, but it is overlay software as well. Okay, so let us jump into my substitute that I might have for you, and let us see if we can find that setup somewhere. I've got, I could close some of a few instances, close that browser so I do not use up too much RAM that is precious. Over here, now I want you to have a look at this. Now this I find extremely useful. I want to share this with you, but just in case you're not already aware of this, you know, providers of infrastructure as a service like Google and AWS, Microsoft Azure, Amazon's AWS and Microsoft Azure, you know, are doing a lot of great things these days by giving free trials to users to, you know, get to experiment with their platform, right? And AWS offers, you know, a free trial for a few days, I think, something like that. And Microsoft Azure does something similar. But I'm inclined to use the Google Cloud. The Google Cloud platform allows me to use IaaS features, and I teach my students how to use the Google Cloud platform and leverage some of the computing power, you know, that is out there in the cloud, you know, like memory. We don't often have enough memory to run, you know, some applications on some simulations. Well, the good news is you can use these resources online. And the better news is you get to use some free time as well. Well, let me tell you about the Google platform if you're not aware of this. Well, the Google Cloud platform, you know, I think they're still offering $300 of free usage for about, I don't know, 30 days or 60 days, right? That's great. You know, for $300 in 60 days or thereabout, you can do so much. You can use, you know, resources that you normally wouldn't have access to. So I'll give you an example. When I run GNS3 on my laptop, for those of you who've used GNS3, which is a network simulation, or rather network emulation software, better than simulation, the problem with that is that it's pretty hungry. You know, it uses a whole lot of resources, right? So for example, you would have to install a VMware of some sort, right? And install a GNS3 VM server on your system locally. And you'll have to spin that server up before you use your GNS3 so that you can run your topologies, which could be quite complex, right? That shuts down your system, or not unless you've got plenty of RAM. If you've got, I mean, my machine has only got 16 gig of RAM. You know, machines with 32 gig of RAM would do better, and so on, 64 gig of RAM. But you know how expensive it is to purchase RAM. So what I've done is taken advantage of the Google Cloud Platform free tool. I'm paying now because my free usage has expired, but it's not that expensive, pretty cheap. So I encourage you to have a look at Google Cloud. Now, in my Google Cloud platform, I have acquired a GNS3 server, meaning I would not be using my GNS3 server on my virtual machine on my laptop, because that's going to take a whole lot of resources. I've only got 16 gig of RAM. And my students are doing this as we speak in executing some of the complex topologies that we've been talking about with SD-WAN and DMVPN and the rest. Okay, so I signed up to the Google Cloud platform, and I spun up a GNS3 server, and my GNS3 server is running, as you can see, got that running. I'm in the Europe West zone, and I've got an internal IP, and I've got an ephemeral IP external. Okay, that's an external IP of 34.140.166.30. You know, I can connect to that using an SSH shell, you know, to connect securely. So my server is running in the background. You know, it's got a fantastic CPU that I picked and plenty of disk space. So it works pretty well. Now, let's jump into this environment. Now, what I wanted to do with you, if I go back to my projects over here, here are several projects that I run on my Google compute server. On my Google compute server, as you can see, there's several labs here that I teach to my students, you know, from advanced OSPF to CCNP and NRC and Core Lab and the rest of it. There's some routine protocols that are taught and troubleshooting, and then eBGP and the rest, and DMVPN, just to mention a few. There's SDN going on here, which is what I would like to do with you today. But the problem with the SDN setup I've got here.
We cannot see the screen, Cliff, in fact.
Oh, my apologies. Thanks for telling me. Let me stop the share and share again. Thank you. These are the things we need to worry about sometimes. Can you see my screen now?
Yes.
My apologies. Thanks for the feedback. Okay, let me backtrack a little bit. Initially, I was talking about my Google server. You might not have seen that. Google Compute Cloud, I've got a GNS3 server running remotely so that I can benefit from the CPU and the memory and the hard disk in the cloud, right? This service was free initially, $300 free service for about 79 days or 100 days. I'm not sure how many days, but it's still going on. Sign up to this service. Once the service expires, then you'd have to pay. What I'm paying at the moment because I've used up my service, but it's still a cheap service to use. So it's pay as you go, okay? So when you're running Google Compute services, you pay for the service as long as it's running. Do not forget to turn your servers off because it is just gonna be using up your cache, all right? So back to my solution. So I've got my Google server running in the background. Here on my browser, I've got a version of my GNS3 server running locally, but using the remote server. Okay, so that's what's going on. Now, this is an SDN lab, but there are a few problems with this lab because in my NAT cloud, I'm connected to a D cloud. So this allows me to connect to the outside world. This is exciting, right? So I can connect my GNS3 topology to the outside world. The benefit of that is that I've got an external controller sitting somewhere on an Ubuntu computer that I'm able to talk to. So the idea is I can write some Python scripts to my controller that is external of this network, and I can push that information down to the Open vSwitch and blast that onto my Cisco devices and get them configured. So imagine this were my vEdge devices right here. Remember we talked about vEdge devices around, right? Well, that makes it a lot easier for me to populate my information. But there's a problem with this because right on my NAT cloud over there, I'm connected to the D cloud platform, and that's where I've got some services that I need to run. So I'm not going to be able to run this SDN demo right now, but I've got a different demo that I could show you, okay? So we do not waste the time. So if I could open a demo for DMVPN. Now, you're possibly wondering why DMVPN and not SDN? Are they different? Well, DMVPN is a WAN technology that allows us to bring separated locations together. Imagine we've got a campus that has, you know, a number of locations. Now I'm going to mimic Middlesex University, for example. Yes, we cannot do SDN, but I'm going to show you DMVPN, which does use overlay technology, right? So I get to do these labs on a GNS3 server using Google Compute resources. It's pretty good. So I'm going to turn on all my devices by turning them on. As you can see, they go on right there. And in this particular topology here, this is something similar to what we're discussing with SDN, but only that it's not SD access. This is DMVPN, which is an overlay technology, but similar constructs, but not so much the performance we get with SDN. But let's have a look at this closely. Over here is Middlesex University, Hendon campus, for example, okay? So at the campus, we've got an edge router sitting over there, R1, right? And imagine we've got a campus in Dubai and Mauritius, and we've got other campuses around. So in the Mauritius campus, we've got another edge router sitting over there, and in Dubai campus is another edge router. But of course, remember, we're not going to just have one edge router per campus. We need multiple edge routers because of redundancy and reducing a single point of failure, right? Now, right in the middle here, I've got a switch. This switch allows me to integrate all of these devices. Well, this switch really is the internet. This is the cloud. This is the cloud. This is the dangerous part of the network that I need to tunnel through. Now, likewise, in SDN and SD access, we create tunnels. We create some secure tunnels to be able to go through the internet. But we're using DMVPN, dynamic multi-point VPN. The difference with this type of VPN from normal VPN is that a head office such as Hendon is able to allow multiple spokes, Mauritius and Dubai and more, to dynamically connect to the head office. That's great, okay? It means I can set up a new branch very easily in a different location. All I need to do is get them a vEdge device, get them an edge router, get it to call back to the head office, and it gets configured. It's as simple as that. But let us have a look at DMVPN. It operates slightly differently. In this particular visual, we can see the underlay network. Without an underlay network, you're not getting to the overlay. So my underlay network coming from the Hendon hub router, edge router, has a network of 192.0.2.0/30, right? And hooking up to a switch over here, call this service provider maybe. To this network, I've got the 203.113.0 and the 198.51.100.0. This here forms my underlay network. But if I was to securely talk to Mauritius so that all my data is not looked at by the ISP and all my data is wrapped up in IPsec, well, what I want to do is set up a tunnel, a VPN tunnel. Well, not just a normal VPN tunnel. I want a GRE tunnel. Now you're possibly wondering, GRE? Well, GRE is a generic routing encapsulation protocol. Generic means GRE is going to allow me push all of my protocols in Mauritius across to Hendon and push all of my data in Hendon across to Mauritius, all my routing protocols, all my ARPs. What else can I push? All my STPs if I wanted to. It would appear that Mauritius and Hendon are in the same location. That's what GRE allows you to do. But the problem with GRE is that it's not secure. All of that data goes in clear text. So if you're thinking like I'm thinking, it would be nice to wrap up that GRE tunnel in IPsec. IPsec, as you know, provides encryption, integrity, and availability, right? So we must leverage IPsec and wrap up our tunnel and make it a lot more secure. So a GRE tunnel is set up between head office and Mauritius, Hendon and Mauritius. This provides a secure tunnel through the internet on 100.100.100.0. And another, you see that same tunnel over here? It's the same tunnel, 100.100.100.0/29, but there's a different endpoint address. So at the hub, we've got 100.100.100.1, and Mauritius, we've got 100.100.100.3, and at Dubai, we've got 100.100.100.2 right here, which means I can securely go through those tunnels and talk to my branches. And with the help of GRE, I can exchange everything in Dubai to Hendon and vice versa. And then with the help of IPsec, all of that can be secure and we're good to go. That is very similar to what SDN does. Let us have a look at this in operation. We've got a few minutes to run this lab. So as you can see, my configuration my devices are all up and running. I encourage you to use this tool if you're not already aware of it. I'm going to come up with some control plane, okay, or rather some command line, right? So I'm going to open up R1. Let's clear some real estate and put that on the corner over here. So I'm going to put this at the top over here so you get to see my network, okay, to some point right here. Okay, I can move this to the side a little bit. So over here, I've got my R1 device loading. Yep, as you can see, my CLI is open over there. Let's open my R2 and go to the console, and R3, I want to be talking to all three of them as well. Okay, so right here, I'm going to move my console to the right, and let's jump on the first router, R1. These are already pre-configured. Because I didn't want to do all the configuration now, it would take time, but I've got the configuration code I can share with you if you're interested. I'll make that available. The scripts are available as well, okay, if you're interested in that sort of stuff. Now, R1 is Hendon, the hub, right? So at the hub, you know, right now I'm on the router, it's called R1, the configuration has been done. And what I could do is do a show run on this router, just to have a look at what's going on underneath the hood. Okay, let's bring up R2, get it ready. And let's bring up R3 and get those ready as well. Okay, so back to my R1 setup over here. Let us have a look at what R1 is doing. What's the business of R1? Well, it has a configuration named R1. What else have we got on this device over here? Let's hit more. Okay, I've got some configuration on IP domain lookup. Okay, that's not so much what we're interested in. Look at the tunnel right here. This is what we want to know on R1. So this is router 1, Hendon hub, head office. Look at the configuration on this tunnel. Well, we created a tunnel called tunnel number 1, right? According to the diagram over here. We specified the bandwidth on the tunnel. We gave the tunnel an IP address of 100.100.1. Yes, is that right? Yes, it is, because the tunnel has to have 100.100.0/29 network. So the .1 on that interface, we put that on the tunnel. We use an MTU value. Those values are modified because GRE adds a bit more to the packet. We can leave that for another day discussion. We use NHRP, the next hop redundancy protocol. Why do we need that? Well, think of this. The overlay is going nowhere if it doesn't know about the underlay. So NHRP, the next hop redundancy protocol, allows us to map the underlay to the overlay. So here is an overlay address of 100.100.1 for the tunnel on the hub. Well, guess what? It has to be mapped to what? The underlay address. And what is the underlay address of this particular hub? Right here, 192.0.2.1. If you have a look at this network over here, 192.0.2.1. So my overlay network over here needs to map to my underlay network over here. The next hop redundancy protocol, NHRP, allows that mapping to take place. Now, we also adjust some values with the packet. We give the NHRP an ID and so on. And then in the tunnel, we're saying that the tunnel source is going to come from the gigabit 0/0 interface. And where's that interface? Right here. And that's where the underlay address is. That's just a command over here that allows GRE to happen, multi-point GRE. Now think about this. Multi-point, head office must have multi-point GRE. Why is that? Because everyone from the branch, from Dubai, from Mauritius, from all of the branches need to register with the head office first. So multi-point means as the head office, I'm going to allow multi-point connectivity from different spokes, from different branches. And I want to make sure that those branches that come to talk to me need to have the pre-shared authentication key. In that way, we ensure there's no rogue connectivity coming toward the head office if we wanted to. So all this here is just the configuration we put on the interface of the router. Okay, so we've looked at the tunnel. Now, what else does the tunnel tell us? Well, there's quite a few things we can do on this tunnel. Let's see what else we have going on this configuration. Well, we've got EIGRP. I used EIGRP to be able to set up my routing. Remember, routing is also necessary in your network. So I've got EIGRP for my routing and so on. So let me test this network to see if it does exactly what I want it to do. So I'm in R2. I wanted to be able to talk to Dubai. Dubai campus wants to talk to Mauritius. I'm going to execute a ping first to see if I can ping one of the IP addresses in Mauritius, and that's 172.16.3.1. Can I reach 172.16.3? This network is already built anyway, so can I reach? Yes, you can see I can reach Mauritius on the 172.16.3.1 network from Dubai. But what I'm interested in is I want to see the path the traffic takes, right? So at the moment, traffic in my tunnel should go like that to my router and then come back down to Mauritius, right? You would expect that. So let's do a trace route on that address to see the number of hops that it's going to take or the specific route that it's going to take. So let's do a trace on that destination. Now, if you have a look at the trace on that destination, look at what's happened right here. Well, the traffic didn't have to go all the way to Hendon before coming down to Mauritius. Look at the track it used. This is a tunnel address, 100.100.100.3. Because if it went to Hendon first, you would see 100.100.100.1 and then 100.100.100.3. But guess what's happened? I can tell you that this network is very smartly tunneled from, let's see if we can get a pen. There's that's not what I wanted. I wanted to annotate that, so I get a pen. So this network has simply gone from here to here. Initially, the network would go in that direction and then come back down to Mauritius. What this is saying is that this has created a secure tunnel, a dynamic route, a dynamic tunnel to go from Dubai to Mauritius. Look, if we come over here, back into this and test that experiment system one more time. Let's go to show run. I want to see, let's pipe that with section. What I'm looking for is NHRP commands. So let's pipe and see what is making that happen. Maybe not there. Let us pipe and do show run. Have a look at that configuration again very quickly. Where are we? I'm looking for the redirect command. Maybe I should be able to show you that directly on my system. Okay, just 1 second. Let's go to R2 and see if we can find it there. I wanted to show you the command that was doing all the magic for us. Okay, what I could do to make life a lot easier is go to the text edit and look at my configuration right here, okay, which I'm going to make available to everybody. Okay, over here, I'm looking at the hub I want to look at. Yes, my script that did exactly everything I wanted it to do. So this is the H1, this is Hendon hub configuration. This was where I set up the tunnel initially. Okay, if you remember that configuration point, we saw this configuration for the tunnel, right? And then what we also wanted to show you was this command, IP NHRP redirect. IP NHRP redirect. Now, IP NHRP redirect is a way of telling this device to redirect the communication because we expect traffic to go in this direction normally. We expect our traffic to go in that direction and that direction, but that didn't happen when we used traceroute. Our traffic just went in that direction. The reason that works is because here we've got a command that is a redirect command. This redirect command says to the spoke, look, you don't need to come through me to get to Mauritius or Dubai. I'm going to give you a better route to get there, and you can go directly. And that's all that is happening with the redirect command from the spoke, from the hub. And then what the spoke does to be able to receive that redirect command, it just needs to say, let us go to a window and have a look for the spoke. It just needs to say over here, spoke just needs to say, hey, okay, you've just sent me a redirect command. Well, that redirect command contains the shortcut of how to get to Dubai or Mauritius without coming back up to the head office all the time. And I'm going to store it in the IP NHRP shortcut command. So long as you do that in the client spoke, as well as do it on the other one, spoke right here, then you're happy to receive that route. Okay, so going back over here, we've got a few minutes left. Going back over here, I'm going to attempt to remove the shortcut command. Let's see if that works, okay? So let's do this, see what happens. So over here, if you see what I did first, let's have a look, let's do a trace again. And that's R2, let's come to R1, let's do a trace one more time. When we do a trace, it's using the tunnel and it's going directly, as we saw, directly from that point to that point. That is dynamic VPN, that's good, spoke to spoke. That is similar to SDN. Only that SDN outperforms the DMVPN, allowing me to go straight to the tunnel. But what if I remove that IP NHRP redirect command? So I'm going to go into the tunnel. I'm going to go into the tunnel configuration on the hub, which is R1, and I'm going to say interface tunnel. What's that? Tunnel number 1. Okay. Remember, I want to remove the IP NHRP redirect command. I'm saying do not redirect. Do not tell them to go directly. So I'm going to do this. Okay, no redirect commands on R1. So what's going to happen now? From Dubai. Oh, have I done something slightly different? I think I've done this in a bad way. Let me put that redirect back. I was looking at the wrong device. So here I am from Dubai to Mauritius. So let us ping 172.16.3.1. I'm trying to go from Dubai to Mauritius, R2. That's what I wanted. Successful. But let me trace to see the path it takes over here. So trace very quickly. Can we have a look? Well, there we are. This was the problem I wanted to highlight, right? Have a look. For Dubai to get to Mauritius, guess what happens? All of that traffic has to backhaul all the way to Hendon and then come down to Mauritius. That's not good for performance. I mean, you don't want to be going all the way to the head office to come back down to a location that is next to you. That's poor performance. So what we want to do is we want to tell this box over here to let this box know to take a different route, okay? Because as you can see, it's going up here. We wanted to go directly from here to here. So let us change that. So I'm going to go into the conf mode over here, okay? Let us change that. So I'm going to R1 in the conf mode, and I want to say, I want IP NHRP redirect, which wasn't there previously. So I want some redirects. And I'm going to say to these guys over here, right, these boxes, I'm going to say, I want you to receive that redirect message. And how are you going to receive it? I'm going to put a configuration line that I'm going to use. So I'm going to say IP NHRP shortcut. Receive the redirect from R1 and store it in a shortcut over there. Okay. And I also want to do something like, if I look at the show run over here, I would have multi-point gray. So I'm going to do something like this command over here. Let me just cheat, cut and paste it in there and do a multi-point gray to allow that configuration to be taken everywhere. Okay, that's failed because it has a tunnel destination. So how do we find that tunnel destination? Do show run. Let's get rid of the tunnel destination because it's saying point at a specific device. I don't want it to point at a specific device. So I'm going to get rid of that configuration on the tunnel destination. Can you see this tunnel destination over here? I want to remove that, okay? Because I don't want it pointing at a specific device. So I am going to do something like this, going back into that mode. Over here, I'm still in the tunnel. So no IP NHRP. What do I want? Destination. I believe so. I'm pretty sure that's what I saw. Let's double check that one more time. Yep, tunnel destination, it should say. I'm pretty sure we do that under the tunnel. Exit 1 second. Interface tunnel 1. Okay, so if we have a look at the several commands, contextual help. Okay, I've just got to do is take this command over here and negate it, right? So let's come over to the tunnel destination under the tunnel itself. Okay, so do this. Now, tunnel destination, no more. So now we can take multi-grad. You see the tunnel's gone down. So now we can do a multi-grad. It should accept this command now, right? It likes it. We've got the shortcut and the tunnel was turned down and restarted. Let's do the same for R3 very quickly, okay? So R3, we go into the conf mode, okay? And we go into the tunnel. And it's tunnel number 1. One of the first things we wanted to do was IP NHRP shortcut to start the tunnel address. And then one of the other things we wanted to do was tunnel destination. We don't want a tunnel destination, right? Remember that? No tunnel destination on that one. Remove it. And then what we wanted to do was do a tunnel mode multi-grade point. It likes that. So we can end. Have a look at what we're going to do now. So I want to test now from R2 Dubai to go to Mauritius. When I execute, let me make sure I can still reach ping. I can still reach Mauritius. But what do I want to happen? Let us think about this. The first traffic is going to go in that direction and it will come down here. The second time we trace it, it's going to go directly across. So let us trace. Let's try. Okay, it's already built the tunnel. Look at what's happened. It's already built the tunnel. So it is now going directly from Dubai to Mauritius because of those configuration changes that I made. Okay, it's now 11:59. And I think we're getting to that point of the day where we have to stop. But there's so many other things I would like to show you and share with you. It's endless. But I'll make these files available with the coordinator and then you got access to them. I hope this session has been useful to you. Thanks for attending and thanks for joining me this morning from wherever you are. It's been great having the group here listen to this session. And I just want to say thank you for coming. Thank you.
Thank you so very much, Cliff. It's amazing. I really appreciate it. I know you have back-to-back lectures as well. I just finished mine. Guys, Bahar and Farzad will get communicating with Cliff and collect the slides or anything, and we will have the recording soon for you. Now we have 1 hour break, and we will join for Osama, which I can see there. Osama, 1 hour from now is your session, mate, yeah?
Yes, that's fine. Yeah, I'll see you guys all in about 1 hour. Have a good lunchtime break, and hopefully you'll be ready for me.
I'll start the session, and hopefully I will be multitasking, Osama. So sorry, Cliff, that I left you on your own there.
No worries.
George, it's you know how it goes with these sessions. There are so many people that need to be on hand just to make sure there's no failure. I'm just going to keep one eye looking at things on the screen while I multitask as well. So, you know, you might be able to shout at me to do one or two things.
Thank you very much. I'm going to stop the recording now, guys. And